Today we would like to begin discussion on logarithms. Now, logarithms are perhaps something that we have not dealt with before, so they're a little bit different. They deal with exponents from a different point of view. If I wanted to know what exponent would give a given result, that's where logarithms come into play. Now, I want you to understand, as we get started with logarithms, that our comfort level being very low at this point in time, perhaps, we're going to work with some things that are going to play very nicely at first. Some of these things we might not see the need for logarithms. Hopefully a little later I can explain maybe the need and get into that. Maybe not this section, but another section later down the road. One of the main parts of logarithms that I think we need to know is how to get from a logarithmic way of writing things to an exponential way of writing things. So if we took something like log base b of a equals x, and really all three of those things are variables, b, a, and x, we want to be able to write that in exponential form. So this would be considered logarithmic form, and this would be considered the exponential form then. The b, it's called a b in the base of the log base b, you will hear it said, is actually the base of an exponential statement, and that's part of where that comes from. The x is actually the exponent that goes with the b, and the a is the result that would have happened. Okay, so these three things, the a, the b, and the x, are back and forth exchangeable between writing something in a logarithmic form or in an exponential form. Now, which one is going to be more beneficial to you is going to depend on the situation, and that's going to then determine later on which way you want to write something. It might be useful to find out what x is, and then write it in a logarithmic form and use your logarithm properties and skills to find out what x is. As we're getting used to this right now, we're going to look at it more often than not moving to exponential form today to kind of see how those things work. So let's write these guys as logarithms. If I'm going to write this guy as a logarithm, I'm going to write log, and I'm going to go base 2, and it's going to equal the exponent, and log base 2 of 8 would equal that result. And this is literally all we're going to do. We're just going to translate from one thing to another. So these are not equivalent to each other, but they're using the same values and would have a truth in either way, written as an exponential form or written in logarithmic form. All right, let's do the same thing here. Let's take this written in exponential form and let's write it as a logarithm, okay? Our base is 25. Our result is 5, so that's what's going to end up going on this first side. Our base of 25, our result is 5, and that would be a 1/2. In other words, 25 to the 1/2 power is 5, or the square root of 25, I'm sorry, yeah, the square root of 25 is 5. That works out. Let's take a look at this last one. Okay, 3 to the negative 4th is 1 over 81. Well, that means log base 3 of 1 over 81 would be negative 4. Okay, that's how we're going to go back and forth between those two values. You're going to be asked to go back and forth between those two values, and then you're going to be asked to evaluate some logarithms or simplify some logarithms. And to give you some steps to go with, and you can use them if you'd like, or you can kind of use your intuition as it sees fit. The easy way to do it is to simply set the expression equal to a variable. You now have gone from an expression to an equation. But you can take your equation now and turn it into exponential form and then solve as you have solved exponential things before. Okay, so get a variable so that you create an equation. An expression doesn't have an equal sign. Okay, you create an equation, you can now put that equation into exponential form and solve that equation for that variable, what it would have been before. The limitations. There are some limitations to solving this way. That's assuming that this is possible. All right, and that's part of why we start dealing with logarithms in the first place. This will not always be possible, and we will find other ways to solve logarithmic equations in the future that use the logarithms as opposed to use the exponential form, but we need to become comfortable with our logarithms before we're able to do that. So let's simplify these guys here. All right, so we have the log base 5 of 125, and what we're going to do is simply make that equal to x. And now I'm going to do a rewrite. So my base is 5, my exponent is x, and I result in a 125. And now I'm going to solve that the way I would have in the past. I'm going to take the 125 and I'm going to make that into a 5 cubed, which means x would have to equal 3. So what is log base 5 of 125? It is 3. Okay, do the same thing with this one here. We have to set it equal to a variable first. Now we have an equation. Now we can use our rewrite process. We'll go a 3 to the x equals 1 over 81. Now you get to the fractions and some people get confused by that, so let's go slowly through that for a second. Let's make it into an 81 to the negative first power. And then let's take the 81 and turn it into a 3 to the fourth power to the negative first power. And then we can multiply those exponents together. Once again, I'm going very step by step through this so that we don't make any misunderstandings or misconceptions. And we can find out that our x value is negative 4. Last couple here today. All right, let's do it the same way. A little bit more interesting. We'll have a 25 to the x power equals a 5. Now this one's a little different because where the x is actually the one I want to change the base on. So I'm going to change this into a 5 squared to the x power equals 5. Or a 5 to the 2x is the same as 5 to the first. And now I'm going to create an equation out of that. Those exponents would have to be the same. And I can find that x is 1/2. All right, let's try this again with this last one here. We'll make log base 16 of 1/2 equal to x. We will take our 16 to the x power equals 1/2. Okay, and from there we will take and go with a 2 to the fourth power for our 16 and a 2 to the negative first power for our 1/2. Now we have everything in base of 2. Let's go ahead and make it into one exponent though in both cases. And we can take those exponents and set them equal to each other. And we can find that x is a negative 1/4, which means log base 16 of 1/2 is equal to negative 1/4. That's how I would simplify that. Should probably go over here and say the same thing. Log base 25 of 5 is 1/2. That's how we would simplify that. I hope this is a good introduction to you in terms of what logarithms are, how they work, and how we can utilize them.